Hello, this is Tyler Beamer from Haywood Community College. This is an instructional math video for Math 152 IN1. The purpose of this video is to describe how to use the graphing calculator as an aid in finding linear correlation and also computing linear regression. I am using the Chapter 10 Section 2 notes as a guide for this video. As you can see, I have those here on my screen, and I'm going to use example 1 as the working example throughout the video. So in example 1, says the member of the board of directors of a non-profit organization that held a fundraising auction. He recorded the opening bids suggested by the auctioneer and the final winning bids for several items. The amounts are listed below. Is there sufficient evidence to conclude that there is a linear correlation between the opening bids suggested by the auctioneer and the final winning bids? Use alpha equal to 0. Okay. So first thing that you want to do is you want to input your data into the list. So if you go to Stat and Enter for edit, and you'd want to put your X values in for L1, Y values in for L2. So we're going to use the opening bids as the X values, winning bids as the Y values. So your L1 would represent the independent variable, L2 the dependent. So we're saying that the opening bids would be independent and the winning bids would be dependent of that opening bid. Okay. Our null is that rho is equal to 0, meaning that there is no linear correlation, and the alternative is that rho is not equal to 0, meaning that there is a linear correlation. Okay. So we've got our data in our list. Next thing would be to graph the data. It's always important to graph the data so you can get a good visual. And what I would do is to go to second stat plot, so second y equals. Make sure that your plot 1 is on. So if you hit enter, make sure it's on. Make sure you're graphing a scatter plot. You want the X list to be L1, Y list to be L2. You can choose whatever marking. I like to use the square. Okay, and then from there I would hit zoom and 9, which is zoom stat, and that means your calculator will automatically fit a window to the data. If you have something in Y equals, you want to just clear that out. That way you're not graphing any extra stuff. So here's our scatter plot. So we've got 5 data points, 5 bids, and you can see that there is somewhat of a linear correlation there. It looks like our data is trying to form a line with some type of positive slope. So that's why you would want to graph the data and look at the scatter plot, is so that you can interpret any type of patterns that you see within the data graphically. So, alright. And if you notice on these notes, I have screenshots of the calculator, and I have instructions here on the notes, but I'll, adding the video as well, because sometimes it's also helpful to see someone doing it. Okay, so the next thing is to turn the stat diagnostic on. So you can do that a couple of different ways. You could hit mode, and you just scroll down to stat diagnostic. And just make sure it's on. You could also go to the catalog, which you can get to by second 0. And then if you want to get to the D's, you can hit the alpha button for D, and then find diagnostic on, and then hit enter twice, and that'll turn it on for you. Okay, you need that stat diagnostic on so you can get an R value. So if you do the linear regression and you don't see an R value, it's because the stat diagnostic is not on. Okay, so next we want to do our linear regression using the calculator. Okay, about our data. So hit Stat, and then go to Calc, and then we want number 4, linear regression. And if we hit Enter twice, that will give us our linear regression. And this linear regression is the modeling of the line of best fit. So if we go back to our scatter plot, the line of best fit would be the line that I would draw through the majority of these data points, kind of through the middle, right? And this equation that I'm given on my linear regression is the equation that would model that line. So we can use this linear regression for a number of different things, mainly for prediction, which we're going to talk about here in a little bit. So A is the slope, and B is the y-intercept, and R is the correlation coefficient, and that R value tells us if we have a linear correlation amongst our data, basically saying, can we use a linear regression to accurately model this data? That correlation coefficient is on a scale from -1 to +1, with 0 being in the middle. A R value close to 0 would mean that there is no linear correlation, meaning that my data could not be modeled with a linear regression. The closer my R value is to +1, the more accurate, or the stronger the correlation I have, linear correlation amongst my data with a positive slope. Okay, and then the closer my R value is to -1, the stronger the linear correlation is I have with my data with a negative slope. Okay, so +1, strong linear correlation with positive slope. -1, strong correlation with negative slope. And 0, no linear correlation. And then of course you could judge the numbers in between. So, alright, but what we're going to do is take that R value and make a comparison with the critical values that are on table A5. So here's our R value. So we want to look at table A5 and find the critical value for our sample size and our alpha level. So our alpha level in the problem is 0.05. Sample size is 5 because I have 5 bids. And if I look at this table, A5, which is right here, and I posted this to Moodle and got it out of the book, we can see that with N being 5 and an alpha level of 0.05, the critical value would be 0.878. Okay, so that would come from the T curve. And if our R value exceeds that critical value, then that tells us that we would have a linear correlation. Okay, so then we would have enough evidence to reject the null hypothesis that rho equals 0. Okay, so we are doing a hypothesis test here when we use that R value and make a judgment. Of course, the table helps us out a good bit, because we don't have to really look at that graphically too much. Okay, so that's one way to determine the linear correlation with the aid of the calculator. Another method is the p-value method, where you are using the test statistic here, and your calculator will calculate that test statistic. Notice the null and alternative hypothesis is the same example. Okay. So you want to once again put the data into the list, which you have already done, and then to use the p-value method, we want to press stat, arrow all the way to test, and we want F, which is linear regression t-test. Hit enter. Okay, we want X list to be L1, Y list to be L2, frequency to be 1. Just saying we want to count all of our data points one time. And we want not equal to 0 for rho. Okay, and then if you want it to put the regression equation into Y1, you can put Y1 in there and it'll do that. So you can graph it along with the scatter plot. Hit calculate. Okay, Okay, and then we should have our results from the test. Here's our test statistic. Here's our p-value, degrees of freedom. Okay, since we're using a t-test, we have degrees of freedom. So the big thing to determine whether you have a linear correlation or not is to look at that p-value. If that p-value is less than the alpha level, then we would have enough evidence to reject the null. And so since our alpha level was 0.05, our p-value is less than that. So that gives us grounds that we would reject the null that rho is equal to 0, meaning that we would have a linear correlation amongst our data. Okay. Other helpful information that you have from this t-test, and I'm going to skip over to the section 3 notes here, is that regression equation. Okay, so section 2 looks at determining whether you have linear correlation. Section 3 takes it a step further and says, okay, we have a linear correlation. You know, how can I define a linear equation that would model my data? You know, so that I could use that for predictions. So our regression equation is going to model this, okay, where we've got b sub 0 y-intercept, b sub 1 is our slope, y hat, okay, is our predictor. So we've got some good information here in the notes. I'll let you read this. Strategies for determining, predicting values of y. But in this case, we've got the same example. Okay, we already know there's a linear correlation because we just did that. So now it says he recorded opening bid, suggested the amounts listed in an item not included in the table is a pair of Knicks. So an item not included in the table is a pair of New York Knicks tickets. The auctioneer's starting bid is $300. Find the best predicted winning bid. Okay, so since that's the auctioneer's starting bid, we want to find the actual winning bid from that. So, and we also want to use alpha 0.05. Is the result close to the actual winning bid of $250? Okay, so have that data in the list, which we've already done. Okay, you can graph the scatter plot again, run the t-test, which we just did. Okay, and then you want to scroll down. Okay, in this t-test, and what you get from this t-test is you get A and you get B. Okay, and those represent the slope and the y-intercept of that regression equation. We also get R value. Okay, so you could really use this t-test for everything, not only getting the equation but finding if there is a correlation. Okay. So since our p-value is less than alpha, we can state that there is a correlation. So now we want to use our regression equation to make a prediction. So notice that B on the screen is the slope and A is the y-intercept, and we're matching it up with this equation at the beginning here that we looked at. Okay, so B1 slope, that's A. I'm sorry. B is the slope, which is B1. Okay, and A is the y-intercept, which is B sub 0. Okay, so you just want to make sure you put the numbers in the right spot. So notice that we've got the same numbers here in both of these screens. So then what that tells us is that I can create this equation from here, right? So notice that B goes in front of the X, that's the slope, and then A goes as my y-intercept. Okay. And then once I have that regression equation, that's the equation of the line of best fit, which allows me to make a prediction. Okay. And actually I've got that equation stored in my y equals now, and when I graph, notice that I've got my scatter plot, and this is my regression equation. It's the line of best fit. So it goes through the majority of those data points, and we can use that as a predictor, right? So, and that's the whole idea, is that we take data and then run our statistics and then find a way to use that to make predictions about unknown values. Okay. So in this case, we would be predicting the winning bid for those Knicks tickets. If the first bid is $300, so $300 in there for X, and then we get $124.11 as the winning bid. And of course we're off, right? So that gives us some indication that we do have some error in our model. Okay. If the actual winning bid was $250, we're off quite a bit from that. So there may be some discrepancies there. We only have 5 data points, so the larger the sample, the more accurate statistics you're going to get. So that has something to do with it, I'm sure. So just remember that, that prediction is just that. It's a prediction. It's not going to be the truth, exactly what happens. We don't have a crystal ball. We're just trying to get as close as we can and make a good estimate, okay, or attempt to. Alright, so hopefully this helps you in Chapter 10, finding linear correlation and the linear regression and making predictions. Okay, if you have any questions, always feel free to email, stop by office hours, and have a good day.